Good evening, students. I hope I am audible. ಕೇಳಿಸ್ತಾ ಇದೆಯಾ? Okay, so I hope you people have logged in through your own names. Apeksha, Lavanya, Priyanka, Sahana, Santosh. ಯಾರ್ದಾದ್ರೂ ಹೆಸರು ಪೇರೆಂಟ್ಸ್ ಹೆಸರಲ್ಲಿ ಇದ್ರೆ ಪ್ಲೀಸ್ ಇನ್ ದ ಚಾಟ್ ಬಾಕ್ಸ್ ರೈಟ್ ಯುವರ್ ನೇಮ್ ಅಂಡ್ ಸೆಂಡ್. ಅಂದ್ರೆ ನಮ್ಗೆ ಅಟೆಂಡೆನ್ಸ್ ಹಾಕ್ಲಿಕ್ಕೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. So if it is registered with your parents name, please write your name in the chat box so that it will help us for the this one, attendance. Yes, Apeksha, Lavanya, Priyanka, Sahana, Santosh.
Good evening, ma'am.
Yes, good evening. So we will wait another just 1 minute. After that we will start with the class. We will see. ಮತ್ತೆ ಯಾರಾದ್ರೂ ಜಾಯಿನ್ ಆಗ್ತಾರ ನೋಡೋಣ. 1 minute wait ಮಾಡೋಣ. Then we will start with the class. Okay. Previous recordings ನೋಡಿದೀರಾ ನೀವೆಲ್ಲ? Because I think ನಿಮ್ಗೆಲ್ಲರಿಗೂ ಇದು ನೇತ್ರಾವತಿ. Lavanya, it is ನೇತ್ರಾವತಿ. Okay, okay. Yes, again, anyone else? So I am writing the attendance and I am keeping your names. So first Apeksha ಬರ್ತಿದೆ, ಆಮೇಲೆ ನೇತ್ರ, then Mahalakshmi, Priyanka, yes, Kiran, Sahana, next Santosh and Priya. Santosh and Priya, okay. So I'll repeat. If anybody joined with your parents' name, please send your names in the chat box. Nagalambika and Manju. Okay, I'll just read out the names. That is, we have today for the class Apeksha, Netravati, Mahalakshmi, Manju, Nagalambika, Priya, Priyanka, then Sahana, Santosh, Diksha. Yes. So if it is your parents' name, please ನಿಮ್ಮ ಹೆಸರನ್ನ chat box ಅಲ್ಲಿ ಬರೀರಿ. ಅಂದ್ರೆ ನಮ್ಗೆ ಅಟೆಂಡೆನ್ಸ್ ಹಾಕ್ಲಿಕ್ಕೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. Okay. ಮತ್ತೇನಾದ್ರೂ ಕನ್ಫ್ಯೂಷನ್? ಸೊ ಒನ್ ಮೋರ್ ಸ್ಟೂಡೆಂಟ್ ಯಾರು ಜಾಯ್ನ್ ಆಗಿದ್ದಾರೆ? ಪ್ರಿಯಾ, yes. Okay, students. So in the last class we have started with, so ನೀವು ಸ್ವಲ್ಪ ನಿಮ್ದು ಇಂಟ್ರೊಡಕ್ಷನ್ ಕೊಟ್ರೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ ಕ್ಲಾಸ್ ತಗೊಳ್ಳಿಕ್ಕೆ. So everybody's attendance I have taken. Okay. Manju, yes, I have taken your name. So you do one thing. ನೀವೇನ್ ಮಾಡಿ ಅಂತಂದ್ರೆ chat box ಅಲ್ಲಿ you just write your name, your college and your place. So it will help us to interact with you. Yes, Mahalakshmi, Diksha, ಮತ್ತೆ ಯಾರಿದ್ದೀರಾ? Total 10 members are there with us for the first time. So I am teaching physics, ಆಯ್ತಾ? Physics ನಾನು ತಗೊಂತೀನಿ. Already electric charge and fields ನಾವು ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ವಿ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ, ಬಟ್ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ 4 ಕ್ಲಾಸಸ್ ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ. ಅದರಲ್ಲಿ ಜ್ಯೋತಿ ಒಬ್ಳೆ ರೆಗ್ಯುಲರ್ ಆಗಿದ್ದು, ಮತ್ತೆ ಎಲ್ಲರೂ ಓಕೆ. ಪ್ರಿಯಾಂಕಾ ಇಸ್ ಫ್ರಮ್ ಬ್ಯಾಂಗ್ಳೂರ್, ಬಸವನಗುಡಿ. ದೆನ್ ಸಂತೋಷ್ ಪ್ಲೇಸ್, Yes, students. Santosh is from Dharwad. Dharwad College, Santosh. Remaining students. If you are interested, ನೀವು unmute ಮಾಡಿ ಕೂಡ ಮಾತಾಡಬಹುದು. ನಾಗಲಾಂಬಿಕಾ, Government View College. KCD. Okay, KCD. Next, remaining students. ಯಾರಿಗಾದ್ರೂ ಇಂಟ್ರೆಸ್ಟ್ ಇದ್ರೆ ನೀವು ಅನ್ಮ್ಯೂಟ್ ಮಾಡಿ ಕೂಡ ಮಾತಾಡಬಹುದು, ಏನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. Today we have Jyoti also, who was regular for all the classes. Lavanya, Netravati. Yes, Netravati is also from same Bangalore. Okay, next remaining. Jyoti, we are doing revision only because other students have joined today. So revision ಮಾಡಿ ನಂತರ MCQs ಅನ್ನ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ನಾವು ಆಕ್ಚುಲಿ ಕಂಪ್ಲೀಟ್ ಮಾಡಿದ್ವಿ. ಪ್ರಿಯಾ ಫ್ರಮ್ ಚಾಮರಾಜನಗರ್. ಓಕೆ, Sapeka, Diksha, what about you? Apeksha, also from Baswangudi. Manju, Priyanka, Apeksha, same. Okay. Priya, then Matyaridira Manju. Okay. This completed. Yes, students. So you want only in English or you want Kannada English mix? ಯಾವ ತರ ಬೇಕು? Your wish. You want only in English? Both? Okay. Yes, other students, your opinion. So once I understood your requirement, then it will be easy for me to take the class. Okay. So almost ಎಲ್ಲರೂ both ಅಂತ ಹೇಳ್ತಿದ್ದೀರಾ. Yes, what about you boys? Okay, done. So okay, we are going to start with the lesson. So now already ನಾನು ನಿಮ್ಗೆ ಹೇಳಿದೆ ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ I think physics now 5 class ಆಗಿದೆ. This is our 6th class. So in the first 5 class, first 4 classes ಅಲ್ಲಿ ನಾವು ಥಿಯರಿಯನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. I think ನಿಮ್ದೆಲ್ಲರದು ಈಗ ಕಾಲೇಜ್ ಕೂಡ ಸ್ಟಾರ್ಟ್ ಆಗಿದೆ. So maybe most of the colleges first lesson, second year ಅಲ್ಲಿ first lesson, that is they will start with electric charge and fields only. Okay. ಮತ್ತೆ ಯಾವ್ದಾದ್ರು ಕಾಲೇಜಲ್ಲಿ ಬೇರೆ ಟಾಪಿಕ್ ಸ್ಟಾರ್ಟ್ ಆಗಿದೆಯಾ? Any other college have started with a different lesson? So maximum all will start with electric charge and the fields. Okay. So electric charge and fields in this lesson, as you people are preparing for the NEET, ನೀವೆಲ್ಲ NEET exam ಗೆ ಪ್ರಿಪೇರ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ಸೊ ನಾವು ಯಾವ ತರ ಇಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ, ಮೇನ್ಲಿ ನಾನು ನಿಮ್ಗೆ ಪ್ರೋಗ್ರಾಮ್ ಯಾವ ತರ ತಗೊಂತೀವಿ ಅಂತ ಹೇಳ್ತಿದ್ದೀನಿ. That is mainly we are focusing on the theory part. Theory ಅಲ್ಲಿ ಅಂದ್ರೆ MCQs ನಮ್ಗೆ ಮೇನ್ ಟಾರ್ಗೆಟ್ ಇರುತ್ತೆ. Yes. So in that theory, whatever we are discussing, ನಾವೇನ್ theory ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ, ಇದರಲ್ಲಿ ಬೋರ್ಡ್ಸ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಯಾವ್ದಾದ್ರು ಇಂಪಾರ್ಟೆಂಟ್ ಡೆರಿವೇಶನ್ಸ್ ಇದೆ, that I'll teach here. ಅದನ್ನ ಬಿಟ್ಟು ಬೇರೆ ಏನೇ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇದ್ರೂನು ಅದನ್ನ ಜಸ್ಟ್ ಸಮ್ಮರಿ ಮಾಡಿ we are just seeing the important part from that. Okay. So here I'll help you with the board exam also. Board ಅಲ್ಲಿ ಯಾವ್ದು ಇಂಪಾರ್ಟೆಂಟ್ ಬರುತ್ತೆ ಅಂತ probabilities. Then we will help you surely for the NEET exam. Yes. So NEET exam pattern ನೀವೆಲ್ಲ NEET ಪ್ರಿಪೇರ್ ಮಾಡ್ತಿದ್ದೀರಾ ಅಂತಂದ್ರೆ most of you know the NEET pattern ಯಾವ ರೀತಿ ಇರುತ್ತೆ ಅಂತಂದ. Yes, 720 marks NEET exam ಆಗತ್ತೆ. In that no Jyoti, Today I think revision only it will take place. MCQs next class al madana. Okay. See, what I was telling, that is we were discussing the electric charge and the field. It is a first lesson. So in this lesson, first we will discuss what is electric charge. Okay. So first now we discuss what is electric charge, what is electric field, the property of electric charge. Then after discussing the properties of the electric charge, we will be discussing about the electric field. ಮತ್ತೆ Coulomb's law study ಮಾಡ್ತೀವಿ. Then Coulomb's law, how it is applicable for the system of the charges. Then electric field. Then electric field ಅಲ್ಲಿ electric dipole ಅಂತ ಕೂಡ ಕಲಿತೀವಿ. And there we will see how it is electric field is calculated for the dipole at two different places, at the equatorial point and at the axial point. Then last ಅಲ್ಲಿ ನಾವು plus ಮತ್ತೆ Gauss law ಅನ್ನ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. ಸೊ ಈ ಲೆಸನ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಫಾರ್ ಯುವರ್ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಆಲ್ಮೋಸ್ಟ್ 5 to 6 ಮಾರ್ಕ್ಸ್ ವರೆಗೆ ನಿಮ್ಗೆ ಈ ಲೆಸನ್ ಇಂದ ನೀವು ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ಬೋದು ಆಯ್ತಾ. For your board exam and for your NEET exam, here you can expect 2 to 3 questions from this. Okay. And next thing is, in this academic year, some of the portion is deleted. So ಕೆಲವೊಂದು portion delete ಮಾಡಿದ್ದಾರೆ. And the deleted portion in this lesson only the conductors and the insulators. So ಬರೀ conductors insulators concept ಅನ್ನ delete ಮಾಡಿದ್ದಾರೆ. ಮತ್ತೆ derivation ಆಯ್ತು, ಯಾವ್ದಾದ್ರು big concepts ಅದನ್ನೇನೋ ಇಲ್ಲಿ delete ಮಾಡಿಲ್ಲ ಆಯ್ತಾ. So let us start. Let us begin with our class today. That is the electric charge and the field. So here we have what is electric charge. Yes. So what is electric charge? It is the charge is the property associated with the matter due to which it produces and experiences electric and the magnetic field anta ಹೇಳ್ತಾರೆ. So what is electric charge here? Actually, here first what happens, how this electric charge come to an existence. So ಯಾವ ರೀತಿ electric charge ಬರುತ್ತೆ, in the Greece ಅಥವಾ ಗ್ರೀಕ್ ಅಲ್ಲಿ whatever the sea shores ಅಂದ್ರೆ ಏನ್ ಸಮುದ್ರದ ದಡ ಇರುತ್ತಲ್ಲ, there some yellow color some sticky substance they will get. ಹೌದಾ, ಆ yellow color substance ಅನ್ನ when they will rub it with the light material like paper ಆಯ್ತು ಅಥವಾ leaf ಆಯ್ತು, ಇದಕ್ಕೆ ರಬ್ ಮಾಡಿದಾಗ what will happen here, it will start attracting those papers, it will start attracting those light materials. So ಆವಾಗ ಏನ್ ಮಾಡ್ತಾ ಹೋಗ್ತಾರೆ, ಇದ್ರ ಮೇಲೆ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಹೋಗ್ತಾರೆ. So how they will produce with the studies, this amber, the properties, they will start studying the properties of this amber. Study ಮಾಡ್ತಾ ಹೋದಾಗ ನಮ್ಗೆ ಇಲ್ಲಿ ಚಾರ್ಜ್ ಕಾನ್ಸೆಪ್ಟ್ ಡೆವಲಪ್ ಆಗುತ್ತೆ. Okay, so ನಮ್ಗೆ ಈಗ ಗೊತ್ತಿದೆ we have the two types of charges, that is the positive charge ಮತ್ತೆ negative charge ಅಂತ ನಮ್ಗೆ ಗೊತ್ತಿದೆ. Yes. So this positive charge here, earlier days these charges are not named as positive ಮತ್ತೆ negative ಅಂತ ಕರೀತಿರ್ಲಿಲ್ಲ. ಮೊದಲು ಇದನ್ನ vitreous ಮತ್ತೆ resinous charge ಅಂತ ಹೇಳ್ತಿದ್ರು. I'll repeat, charges are not called as positive and the negative charges in the earlier days. They used to call it as the vitreous and the resinous charges. So later Benjamin Franklin, ಯಾರಂತ ಅಂದ್ರೆ the scientist name is Benjamin Franklin. So what this Benjamin Franklin will do, he will name the charges as the positive and the negative charges. So charge ಅಂತಂದ್ರೇನು, so ನಾವೀಗ charge ಅಂತ ಹೇಳ್ತಿದ್ವಿ. So what is the meaning of charge? Charge is associated with the matter. ಇದೇನಾಗತ್ತೆ ಅಂತಂದ್ರೆ ಇದು ಪ್ರಾಪರ್ಟಿ ಆಗತ್ತೆ, ಮ್ಯಾಟರ್ದು ಒಂದು ಪ್ರಾಪರ್ಟಿ. ಇದು ಯಾವ ತರ ಪ್ರಾಪರ್ಟಿ ಅಂತ ಹೇಳ್ತೀವಿ, ಇದು ಇಂಟ್ರಿನ್ಸಿಕ್ ಪ್ರಾಪರ್ಟಿ ಅಂತ ನಾವ್ ಇದನ್ನ ಹೇಳ್ಬೋದು. ಸೊ ಚಾರ್ಜ್ ಈಸ್ ದಿ ಇಂಟ್ರಿನ್ಸಿಕ್ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ದ ಮ್ಯಾಟರ್ ವಿಚ್ ವಿಲ್ ಎಕ್ಸಿಬಿಟ್, that is which will exhibit or which will experience electric and the magnetic effect, which will exhibit and experience the electric and the magnetic effect. So what is the meaning of this? Charge ಯಾವಾಗ ಮೋಷನ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಇದ್ರ ಸುತ್ತ ಇದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನ ಎಕ್ಸಿಬಿಟ್ ಮಾಡುತ್ತೆ. ಸಿಮಿಲರ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕೂಡ ಎಕ್ಸಿಬಿಟ್ ಮಾಡುತ್ತೆ. So what is electric field, what is magnetic field ಅಥವಾ magnetic effect ಅನ್ನ ನಾವು next, but how we will continue, we will see that point ಆಯ್ತಾ. So first, so what is electric charge? Charge is the property associated with the matter due to which it produces and experiences electric and the magnetic effect. So ಬೇರೆ ಬೇರೆ ನೀವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ನೋಡಿದಾಗ ಬೇರೆ ಬೇರೆ ಡೆಫಿನೇಷನ್ ಬರುತ್ತೆ. So you can write any of the definition, whatever you will get it from your college. So here I have taken whatever appropriate according to me. Yes, so charge is the property of the matter which produces and experiences electric and the magnetic effect. Then we have the two types of charges, positive and the negative charges. Who named the charges as positive and negative? Benjamin Franklin will name the charges as positive and the negative charges. Okay, so this is the introduction of this part. Next, so we have the properties of the charges. So what are the properties of the charges? The first property, here the only basic property ನಾನು ಇಲ್ಲಿ ತಗೊಂಡಿದ್ದೀನಿ, ಮತ್ತೆ ಯಾವ ಬೇರೆ ಬೇರೆ ಪ್ರಾಪರ್ಟಿ ಇದೆ ಅಂತ ಹೇಳ್ತೀನಿ. ಚಾರ್ಜ್ ಇಸ್ ಎ ಸ್ಕೇಲಾರ್ ಕ್ವಾಂಟಿಟಿ. ಚಾರ್ಜ್ ಇಸ್ ಎ ಸ್ಕೇಲಾರ್ ಕ್ವಾಂಟಿಟಿ. ಸೊ ನಿಮ್ಗೆ ಸ್ಕೇಲಾರ್ ಅಂತ ಗೊತ್ತಿದೆ, ಯಾರಾದ್ರೂ ಹೇಳ್ಬೋದಾ ವಾಟ್ ಇಸ್ ಸ್ಕೇಲಾರ್ ಕ್ವಾಂಟಿಟಿ ಅಂತ ಹೇಳಿ? Can anyone tell me what is scalar quantity? So we have scalar quantity and the vector quantity. How that? So what is scalar quantity?
Quantity which is having only magnitude, no direction.
Yes, the quantity which is having only magnitude and no direction, it is called as what? The scalar quantity. Yes. So here the first property of this charge is a scalar quantity. Then the second property is like charges repel each other and the unlike charges attract each other. So the like charges repel and the unlike charges attract. Yes. So some will understand, some will not understand. So as it is the first chapter, little bit big explanation. ಮತ್ತೆ ಸ್ವಲ್ಪ ಇಲಾಬ್ರೇಟ್ ಮಾಡಿ ಹೋಗೋಣ. ನೆಕ್ಸ್ಟ್ ಸ್ವಲ್ಪ ನಾವು ಫಾಸ್ಟ್ ಆಗಿ ಹೋಗ್ಬೋದು. ಲೈಕ್ ಚಾರ್ಜಸ್ ರಿಪೆಲ್ ಅಂತ ಅಂದ್ರೆ ಲೈಕ್ ಮೀನ್ಸ್ ವಾಟ್ ದ ಸಿಮಿಲರ್ ಚಾರ್ಜಸ್. ಇಫ್ ಐ ಹ್ಯಾವ್ ದ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ದ ರಿಪಲ್ಷನ್ ವಿಲ್ ಬಿ ದೇರ್. ರಿಪಲ್ಷನ್ ಅಂತ ಅಂದ್ರೆ ಒಂದು ಈ ಕಡೆ ಇದನ್ನ ಪುಷ್ ಮಾಡುತ್ತೆ, ಈ ಚಾರ್ಜ್ ಈ ಕಡೆ ಇದನ್ನ ಪುಷ್ ಮಾಡುತ್ತೆ. So if you have positive same, if you have negative also same it will take place. So ನಿಮ್ಗೆ unlike charges ಅಂದ್ರೆ one you have the positive charge and the other one is a negative charge. ಈ ರೀತಿ ಇದ್ದಾಗ there will be the force of attraction between them. Yes, this is the second property. Then the third property is charges reside only on the surface ಅಂತ ಹೇಳ್ತಾರೆ. Charges will reside only on the surface. So what is the meaning of this? Suppose if we consider in body, suppose if I consider anyone, what I am giving the charges to this body. So how I am giving, that is secondary. So I just say that I am giving the charges to the given body. So when I am giving charge to the given body, here whatever the charges are there, it will accumulate only on the surface. It will accumulate only on the surface. The charges will not go inside the body anta ಹೇಳ್ತಾರೆ. So what is the meaning of this? The charges will reside and they situate only on the surface of the bodies, not within the body or inside the body. So this is the other property. So first one, scalar, like charges and unlike charges repel and attract. Only surface will occupy by the charges. Then we have the some three basic properties of the charges. Okay, idon more ಆಯ್ತು. Another three I'll tell you. These three are called as the basic properties. So what are the basic properties of the charge? Adರಲ್ಲಿ first one ನಾವು additive ಅಂತ ಹೇಳ್ತೀವಿ. Charge is additive in nature. So what is the meaning of additive in nature? Meaning is, suppose if I have the system is having the charges Q1, Q2, Q3. Yes. So additive nature ಅಂತ ಅಂದ್ರೆ ಈ total body ದು charge ಎಷ್ಟಿದೆ. So what is the charge of this total body? The charge of this total body is given by sum of whatever the charges are there inside the body. Okay, so our body ಏನ್ charges ಇರುತ್ತೆ, not exactly inside, on the body ಅಂತ ಹೇಳ್ಬೋದು. Okay, actual word for that one, that is on the body whatever the charge is there, the sum of all the charges will give the total charge of the given body or the given system ಅಂತ ಹೇಳ್ತೀವಿ. This is what the additive nature. So ನಮಗೆ ಗೊತ್ತಿದೆ, whenever you see any scalar quantities ಇದ್ದಾಗ ನಾವ್ ಏನ್ ಮಾಡ್ಬೋದು, ಡೈರೆಕ್ಟ್ ಆಗಿ addition subtraction ನಾವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಮಾಡ್ಬೋದು, like mass, like time, temperature. Yes, but if we have the vector quantities, we cannot add it directly, we cannot subtract it directly, we require vector addition method, or it is also called as that is vector multiplication ಅಥವಾ vector additive laws ಅಂತ ಹೇಳ್ತೀವಿ ನಾವಲ್ಲಿ. Okay, but here directly we can add it. This is called as what? Additivity of the charge. So ಇಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ, charges are scalars and they can add up like real numbers. It means that if a system consists of n number of charges like Q1, Q2, Q3, then the total charge is given by Q1 plus Q2 plus so on Qn. Okay, so this is the basic properties ಅಲ್ಲಿ first ಆಗಿದೆ. Then next slide. Yes, So charge is conserved in nature. Charge is conserved in nature. So what is the meaning of conservation of charge? Let us see. So I think in school you might have studied, that is, charge is conserved in nature. So what is the meaning of that? ಅಥವಾ conservation of energy ಅಂತ ಕಲ್ತಿದ್ದೀರಾ ನೀವು ಸ್ಕೂಲಲ್ಲಿ. So can anyone define what is conservation of charge? Sorry, conservation of energy ಹೇಳ್ಬೋದು ನೀವು. So in school you might have studied first year ಅಲ್ಲೂ ಕಲ್ತಿದ್ದೀರಾ work energy chapter ಅಲ್ಲಿ. Yes.
Energy can neither be created nor be destroyed, but
Yes, yes.
it can be changed from one form to another.
Another form. So that is energy either be created nor destroyed. It can be transferred from one form to the other form. That is the conservation of energy. So what is the total meaning of that? The energy is remaining constant. So ಅಷ್ಟೆಲ್ಲ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲ, ಅದ್ರದ್ದು ಏನು summary ಅಂತಂದ್ರೆ the energy is remaining constant. Okay. So here same way conservation of charge ಅಲ್ಲಿ ಏನಂತ ಹೇಳ್ತೀವಿ, the charge is remaining constant. The charge is remaining constant. Okay. Yes. So here you can see the statement, the total charge of an isolated system is always conserved. That is, initial and the final charge of the system is the same. Okay, so this is conservation of charge. Then the very, very important property of the charge, that is quantization of charge. So let us see what is quantization of charge. So you can see here that is given by yes. So quantization of charge means here, that is, the charge of the body is the integral multiple of charge of the electron. So if anybody is there from 10th CBSE, ನೀವು CBSE ಅಲ್ಲಿ ಕೂಡ ಇದನ್ನ ಕಲಿತೀರಾ. Actually state board English medium ಅಲ್ಲಿ ಕೂಡ ಇದೆ ಇದು. Okay, so the charge is the integral multiple. So integral ಅಂತ ಅಂದ್ರೇನು, your n is the, it is integer 1 2 3, it is taking the number integer 1 2 3 ಆ ತರ ಈ ವ್ಯಾಲ್ಯೂ ನ ತಗೊಂತಾ ಇದೆ. Okay, so it is the integral multiple of the charge of the electron. Integral multiple of charge of the electron. Now, can anyone tell me the value of charge of electron? Yes.
1.6 into 10 power minus 19.
Minus 19. Yes, correct. So it is 1.6 into 10 to the power of minus 19. Howda? So here we will write that. Okay. So that is, their charge is the integral multiple of the charge of the electron. So Q is the charge, N is the integer, E is the charge of the electron. So I'll write the value here, that is E is equal to 0.6 into 10 to the power of minus 19 coulomb. So coulomb is the unit of your charge. So then next here, Q is equal to NE. This is only quantization of charge. So sometimes in 1 mark they will ask, questions. So there also sometimes there is a chance, what is quantization of charge ಅಂತ ಬೇರೆ ಬೇರೆ formula ಕೊಡ್ಬೋದಲ್ಲಿ. That is Q is equal to N into E. Yes. So for example, suppose if I am saying the total charge is 1 coulomb. The body is having the charge 1 coulomb, and what is the number of electrons in a body? So my question is, the charge of the body is 1 coulomb. How many electrons are there in the body? Yes. So how to do that? According to the formula, quantization of charge, Q is equal to N into E. So ನಮ್ಗೆ ಏನ್ ಬೇಕಾಗಿದೆ, N, number of electrons find out ಮಾಡ್ಬೇಕಾಗಿದೆ, that is Q divided by E. Okay, so what is Q? ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ, it is 1 coulomb they are saying, divided by charge of the electron 1.6 into 10 to the power minus 19. So which is equal to, it is number of electrons. Okay. Now, suppose if I take 1 divided by 1.6, suppose if I do 1 divided by 1.6, it is 0.625 into denominator 10 to minus 19 is, so numerator it will become 10 raised to plus 19. Okay, which is equal to N. Now, if I shift the decimal and shift ಮಾಡಿದಾಗ 6.25 into 10 to the power of 18 ಅಂತ ಬರುತ್ತೆ. So these many electrons will be there for 1 coulomb of charge. Yes. So that is 6.25 into 10 to the power of 18 electrons are there in 1 coulomb of charge. Okay. So I hope this is clear to everyone. If anybody is not understanding, you can ask by unmuting yourself, or else you can write in the chat box also. Any doubt is there? So these are the properties of the charge here. I hope there is no doubt. So last ಅಲ್ಲಿ ಬೇಕಾದ್ರೆ ಮತ್ತೊಂದ್ಸಲಿ just revise ಮಾಡೋಣ. So this is regarding the properties of the charges. Then the unit of charge, it is coulomb. The other unit, the unit is also electrostatic unit, that is ESU anta navilli helಬೋದು. Then the main law, that is Coulomb's law of this lesson. Okay, so what is Coulomb's law? The Coulomb's law is given by, it states that here we know that if there are two bodies, suppose if we have the two bodies here of charge Q1 and Q2. So new first year only gravitational law kaltidira. So there what we will consider, the two bodies will be there of the masses M1 and M2. Here the M1 body exerts force on M2 body and M2 body exerts force on the M1 body. So the force is taken as F, and this force is proportional to the product of the masses, and this force is inversely proportional to the square of the distance between them. Okay? So this gravitational law, sorry, we will apply it for the that is charge. ಅವಾಗ ಇದೇನಾಗುತ್ತೆ ಕೂಲಮ್ಸ್ ಲಾ ಆಗುತ್ತೆ. ಸೊ ಸ್ವಲ್ಪ ಇಲ್ಲಿ ವೇರಿ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ, instead of mass we will take the bodies of charges Q1 and Q2. So they are separated by the distance of r. Here as we know that whatever may be the charge, plus irli, minus irli, ಅಥವಾ plus irli, minus irli, here both will experience either force of attraction or the force of repulsion. The force between the bodies is directly proportional to the product of the magnitude of the charge. So I'll repeat, here the force between the two charges is proportional to, or two bodies is proportional to the product of the magnitude of the charge. First equation. Then the second equation is, it is inversely proportional to the square of the distance between them. So this is my second equation. So by combining these two equations, I can write it as F is proportional to Q1 into Q2 upon R square. So F is equal to, here I'll take the proportionality constant. So as you know, ನಿಮಗೆ ಗೊತ್ತಿದೆ physics ಅಲ್ಲಿ ಯಾವಾಗನು ಇಲ್ಲಿ proportionality sign ಬಂದಾಗ we will remove that and take equal sign. That is given by F is equal to K into Q1 into Q2 divided by R square. So what is K here? As I told you, it is proportionality constant and its value is, it is 1 upon 4 pi epsilon naught. ಮತ್ತೆ ಇಲ್ಲಿ ನೋಡಿ 4 constant ಇದೆ, pi constant ಇದೆ, epsilon naught is also constant. So what is that epsilon naught? I'll tell you. So first I'll tell you about this one. So this K is containing all the constant values. So if we calculate the value of this K, it is coming out to be 9 into 10 raised to 9. Yes. So this is the value of K. Therefore, what happens to the Coulomb's law now? Let us write the Coulomb's law now. Okay, so now the Coulomb's law becomes, that is F is equal to 1 upon 4 pi epsilon naught Q1 into Q2 divided by R square. Okay. So as I told you, your 1 upon 4 pi epsilon naught value is constant and the constant value is 9 into 10 raised to 9 Newton meter square per coulomb square. This is the unit of that. ಆಯ್ತಾ? So ನಾನು ನಿಮ್ಗೆ ಏನು ಹೇಳಿದೆ, ಇಲ್ಲಿ epsilon naught ಅಂತ ಒಂದು term ಬರ್ತಾ ಇದೆ, and this epsilon naught is called as permittivity. It is called as permittivity. So what is permittivity here? So ನಿಮ್ಗೆ electric lines, field lines ಗೊತ್ತಾದಾಗ ನಿಮ್ಗೆ permittivity ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಅರ್ಥ ಆಗುತ್ತೆ. So you just remember that electric field lines ಅಂತ ಏನಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ನಾನು ನಿಮಗೆ ಹೇಳ್ತೀನಿ ನೆಕ್ಸ್ಟ್ ಸ್ಲೈಡ್ ಅಲ್ಲಿ. So first permittivity is what? Suppose this is one area, ಆಯ್ತಾ? ಇದೊಂದು ಸಿಸ್ಟಮ್ ಇದೆ, ಇದು ಈ ಏರಿಯಾದಲ್ಲಿ how much electric field lines will pass through that. Okay. So the ability of this surface to allow the electric field lines to pass through them, that is called as what? Permittivity anta ಹೇಳ್ತಾರೆ. Okay. So for example, if you consider yourself, so every day you may eat 2 chapatis or you may eat 4 chapatis, 3 chapatis, 2.5. So that is what your ability or your capacity, right? So whatever that ability of your body is there, that is called as the permittivity. But idರಲ್ಲಿ ಏನಾಗುತ್ತೆ permittivity ಅಲ್ಲಿ, here the electric field lines. How many electric field lines will pass through the given body? That is called as what? Permittivity. And this permittivity value is also constant. It is 8.854 into 10 to the power of minus 12. It is 8.854 into 10 to the power of minus 12. Okay. This is regarding the Coulomb's law. So the same everything expression is written in the next slide also. Here I explained you. Similarly, you can see the expression. That is 1 upon 4 pi epsilon naught Q1 into Q2 upon R square. So the value of 1 upon 4 pi epsilon naught is given. Similarly, permittivity of the free space is given. You can see the unit of that. It is Coulomb square per Newton per meter square. ಮತ್ತೆ ಇಲ್ಲಿ ಏನ್ ಕೊಡ್ತಿದ್ದಾರೆ ಅಂತಂದ್ರೆ ದೇ ಆರ್ ಗಿವಿಂಗ್ ಯು ದಟ್ ಇಸ್ ಎಪ್ಸಿಲಾನ್. ನಾವ್ ಈಗಷ್ಟೇ ಏನ್ ನೋಡಿದ್ವಿ? ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ನೋಡಿದ್ವಿ. ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಇಸ್ ವಾಟ್? ಇಟ್ ಇಸ್ ದಿ ಪರ್ಮಿಟಿವಿಟಿ ಆಫ್ ದ ಫ್ರೀ ಸ್ಪೇಸ್. ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಇಸ್ ಪರ್ಮಿಟಿವಿಟಿ ಆಫ್ ದ ಫ್ರೀ ಸ್ಪೇಸ್. ಆಯ್ತಾ? ಇದ್ರ ವ್ಯಾಲ್ಯೂ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ. ಎಷ್ಟಿದೆ? 8.854 ಇಂಟು 10⁻⁻12. ಬಟ್ ಹಿಯರ್ ವಿ ವಿಲ್ ಹ್ಯಾವ್ ಎಪ್ಸಿಲಾನ್. ಇದು ಫ್ರೀ ಸ್ಪೇಸ್ ಬರುತ್ತೆ when the electric field lines are in the space. If it is in the medium, we take it as epsilon. So this epsilon is what? Electric, that is permittivity for the given medium. Idu value kuda constant ide, but vary from the material to material. Constant, ade copper, new copper surface tagoli, ಅಥವಾ ಬೇರೆ ಯಾವುದೇ ಒಂದು ಕಂಡಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ ತಗೊಂಡಾಗ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಸರ್ಫೇಸ್ ಗೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಇದೆ, ಬಟ್ ಬೇರೆ ಸರ್ಫೇಸ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಮತ್ತೆ ಅದಕ್ಕೆ ಅದು ವೇರಿ ಆಗುತ್ತೆ. ಬಟ್ ಫಾರ್ ದ್ಯಾಟ್ ಮಟೀರಿಯಲ್ ಇಟ್ ಇಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಅಂದ್ರೆ ಅಲ್ಲಿ ಏನ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಫ್ಯಾಕ್ಟರ್ಸ್ ಏನೋ ಅಫೆಕ್ಟ್ ಆಗಲ್ಲ ಟು ಚೇಂಜ್ ದ ವ್ಯಾಲ್ಯೂ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಸೊ ದಟ್ ಇಸ್ permittivity of free space, permittivity of the medium. Okay, now here we will learn one more thing, that is the ratio of permittivity of the medium to the permittivity of the free space is called as relative permittivity anta ಹೇಳ್ತಾರೆ, epsilon r. So ಈ ಸಿಂಬಲ್ ಅನ್ನ ನಾವು epsilon ಅಂತ ಹೇಳ್ತೀವಿ. Okay, that is the relative permittivity. Okay, so you can see the relative permittivity is also written here. Then down you can see one more expression is written for the Coulomb's law. It is 1 ಇಲ್ಲಿ ಕೆಳಗಡೆ ಆಯ್ತಾ ಲಾಸ್ಟ್ ಅಲ್ಲಿ. It is 1 upon 4 pi epsilon naught Q1 Q2 upon R square mod of R square into R vector, or mod of F is equal to 1 upon 4 pi epsilon naught Q1 Q2 divided by R square. Okay, so what is the meaning of this? This is just written in the vector form ಅಲ್ಲಿ ಬರಿತಾ ಇದ್ದಾರೆ, vector form ಅಲ್ಲಿ. Okay, ಇದು ಕೂಡ ಕೆಲವೊಂದ್ಸಲಿ 1 ಮಾರ್ಕ್ಸ್ ಬರುತ್ತೆ, ನೀವು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. So up to this, whatever we have discussed for board exam, like Coulomb's law important ಆಗುತ್ತೆ ಇಲ್ಲಿ. ಅದನ್ನ ಬಿಟ್ಟು the properties of the charges, you may get the question. Then the vector form of the Coulomb's law. So these are the 3 points which you need to remember for your board exam. ಮತ್ತೆ ಕಾಂಪಿಟೇಟಿವ್ ಪಾರ್ಟ್ ಅಲ್ಲಿ ನೋಡೋದಾದ್ರೆ ನಮ್ಗೆ Coulomb's law ಮೇಲೆ ನಮ್ಗೆ ಕ್ವಶನ್ಸ್ ಬರುತ್ತೆ. Okay, then the next slide, that is principle of superposition for the electrostatic force. Electrostatic force ಅಂದ್ರೇನೆ ಇಲ್ಲಿ Coulomb's law. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? So electrostatic force is nothing but the Coulomb's law here. So how to explain this one? That is, so here you can see the figure. ನೀವು ಇಲ್ಲಿ ಫಿಗರ್ ಅನ್ನ ನೋಡಬಹುದು. So here if you see, that is we have the x and y axis, the superposition principle of electrostatic force. Here you can see the point at the center ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, ಒಂದು ಚಾರ್ಜ್ ಇದೆ Q0 ಅಂತ. This Q0 is surrounded by the number of charges. It is surrounded by the number of charges like Q1, like Q2. ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಫಿಗರ್ ಚೇಂಜ್ ಇರಬಹುದು, Q3, Q4, so up to Qn. ಆಯ್ತಾ? So ಈ ರೀತಿ Q0 is surrounded by the number of charges here. Yes. So as we know that according to the properties of the charges, the like charges will repel and the unlike charges will attract each other. But what is the conclusion? Each charge will experience the force. ಹೌದಾ? So ಇಲ್ಲಿ ನೀವು Q0 ಮತ್ತೆ Q1 ಇಲ್ಲಿ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಆಗುತ್ತೆ, Q0 ಮತ್ತೆ Q2 ಇದ್ರ ಮಧ್ಯೆ ಫೋರ್ಸ್ ಇರುತ್ತೆ, Q0 and Q3 ಇದ್ರ ಮಧ್ಯೆ ಫೋರ್ಸ್ ಇರುತ್ತೆ, Q0 and Q4 ಇದ್ರ ಮಧ್ಯೆ ಕೂಡ ಫೋರ್ಸ್ ಇರುತ್ತೆ. So similarly for the n number of charges ವರೆಗೂ ಕೂಡ Q0 ಅನ್ನೋದು ಕಾಮನ್ ಆಗುತ್ತೆ. ಬೇರೆ 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 ಚಾರ್ಜ್ ತಗೊಂಡಾಗ ಅದ್ರದ್ದು ವ್ಯಾಲ್ಯೂ ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕು. ಸೊ ವಾಟ್ ಇಸ್ ದಿಸ್ ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಸೂಪರ್ಪೊಸಿಷನ್? ಪ್ರಿನ್ಸಿಪಲ್ ಆಫ್ ಸೂಪರ್ಪೊಸಿಷನ್ ಅಂತ ಅಂದ್ರೆ at this point Q0, what is the total force? That is your principle of superposition. ಅಂತ ಅಂದ್ರೆ I have here the total force as F. This f is given by f01 ಆಯ್ತಾ plus f02 plus f03 plus f04 plus and so on up to f0n ಅಂತಂದ್ರೆ the force between q0 and the q1. Second one, the force between q0 and the q2, force between q0 and the q3. ಈ ರೀತಿಯಾಗಿ ಇದು ಕಂಟಿನ್ಯೂ ಆಗ್ತಾ ಹೋಗ್ತಿದೆ up to where, up to n number of charges. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ನಾವೀಗ ಏನ್ ಮಾಡ್ತೀವಿ ನೆಕ್ಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ, we are just substituting the values of Coulomb's formula. So what is Coulomb's formula? 1 upon 4 pi epsilon naught q1 into q2 divided by r square. So 1 upon 4 pi epsilon naught ಏನಾಗುತ್ತೆ, ಎಲ್ಲದರಲ್ಲೂ ಬರುತ್ತೆ, ಹೌದಲ್ಲ? So 1 upon 4 pi epsilon naught, I'll take it common. And inside the bracket, first ಅಲ್ಲಿ ಏನಿದೆ q0 into q1 upon, so ನೀವು ಫಿಗರ್ ನೋಡಿದಾಗ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ r01 ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದಾರೆ. ಇಲ್ಲಿ ನೋಡಬಹುದು ನೀವು, here it is. So here you can see this one. It is r01, ಹೌದಾ? So that is r01, the force between the q0 and the q1. Sorry, the distance between q0 and the q1. Then next plus q0 into q2 divided by r0 into 2 plus q0 into q3 upon r0 into 3. So on up to we can consider. ನಾನು ನಿಮ್ಗೆ ಇಲ್ಲಿ ವೆಕ್ಟರ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೀತಾ ಇಲ್ಲ, ನೀವು ಇಲ್ಲಿ ಸ್ಲೈಡ್ ಅಲ್ಲಿ ನೋಡೋದಾದ್ರೆ ಅವ್ರು ವೆಕ್ಟರ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ತಗೊಂಡಿದ್ದಾರೆ, ಆಯ್ತಾ? ಓಕೆ, ಸೊ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ನಿಮಗೆ ವೆಕ್ಟರ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಕೇಳಿದ್ರೆ ಅದನ್ನ ಬರೀರಿ, ಇಲ್ಲ ಅಂತಂದ್ರೆ ಯು ಕ್ಯಾನ್ ರೈಟ್ ದ ಸಿಂಪಲ್ ಡೆರಿವೇಶನ್ ಆಲ್ಸೋ. ಸೊ now what is common here students? Can anyone tell me ಏನ್ ಕಾಮನ್ ಬರುತ್ತೆ ಈಗ?
q0.
Yes, q0 is common, so we can take out the q0. Then the remaining terms, that is the total force F is equal to q0 upon 4 pi epsilon naught, and the inside the bracket we have q1 upon r01 plus q2 upon r02, so on up to n terms. Okay, so now whatever this q0 upon 4 pi epsilon naught is there, I'll keep as it is. ಇದು ಒಳಗಡೆ ಇರೋದೇನಾಗತ್ತೆ, we can write it in the summation form. ಇದನ್ನ ನಾವು summation ಹಾಕಿ ಬರಿಬಹುದು. ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಅಲ್ಲಿ ನೀವು ಕಲ್ತಿದ್ದೀರಾ ಅಂತ ಹೇಳಿ I'll assume. Okay, so that is here qi is taking the values. Okay, first ನಾವು ಇಲ್ಲಿ ಕೆಳಗಡೆ ಬರೋಣ, that is r not I, where your I is taking the values from 1 to n. I is taking the values from 1 to n. So ನೀವು ಸ್ಲೈಡ್ ಅಲ್ಲಿ ನೋಡೋದಾದ್ರೆ ಅವರು ವೆಕ್ಟರ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರ್ದಿದ್ದಾರೆ, and it is in mod, so therefore they have taken it like r0 minus right. Yes, so everywhere it is square square square. Then so this is what, this is your Coulomb's law, principle of superposition for the Coulomb's law, or you can also say that the superposition principle for the electrostatic force anta kuda ಹೇಳ್ತಾರೆ. Yes, understood students? Repeat ಮಾಡಬೇಕಾ, ಅರ್ಥ ಆಯ್ತಾ? chat box ಅಲ್ಲಿ ಹೇಳ್ಬೋದು, ಅಥವಾ you can unmute and tell. Repeat or understood? I hope everyone is understanding. Then last one more concept we will explain. Then after that, your doubts. If no doubts, we can end the class. So two concepts discuss madana, adar nanತರ we can end the session. Okay. So next is the electrostatic force due to continuous charge distribution anta ಹೇಳ್ತಾರೆ. So here we are learning some of the definitions. You can see the figure here. Okay. So ಇಲ್ಲಿ ನೀವು ಫಿಗರ್ ನೋಡಿದಾಗ ಫಸ್ಟ್ ಅಲ್ಲಿ ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಜಸ್ಟ್ ಒಂದು ವೈರ್ ನೋಡ್ತಾ ಇದ್ದೀರಾ, or a conductor. Then you can just see some square surfaces there. ಇಲ್ಲೊಂದು ಟ್ಯೂಬ್ ತಗೊಂಡಿದ್ದೀವಿ, ಆಯ್ತಾ? So what is this? The region in which the charges are closely spaced is said to have a continuous distribution of the charges. Okay, so ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ, whatever the charges are there, they are getting distributed on the surfaces, and there are of the 3 types. ನೀವಂದ್ರೆ ಯಾವ ಶೇಪ್ ಇದ್ದು ಯಾವ ನೇಚರ್ ಇದ್ದು ಬಾಡಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀರಾ? Based on that we will have the that is charge distribution. Suppose if you consider a wire, the charge distribution on the wire, it is called as linear charge density. It is called as linear charge density. So this linear charge density is denoted by the letter lambda, and this is defined as charge per unit length. The linear charge density is defined as the distribution of the charge is there along the line of the given wire or the given surface, or the length, along the length anta helbodu. So it is given by charge per unit length. Okay, so what is charge unit? The coulomb is the unit of charge. Length is measured in terms of meter. So it is coulomb per meter. It is not centimeter. Okay, it is coulomb per meter. Similarly, the second definition is surface charge density. So the surface charge density is denoted by the letter sigma, which is equal to charge per unit area ಅಂತ ಹೇಳ್ತಾರೆ. ಇದರಲ್ಲಿ ಯೂನಿಟ್ ಏನಾಗುತ್ತೆ? ಏರಿಯಾ ಯೂನಿಟ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಇದೆ. ಸೊ ಇಟ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ದ ನ್ಯೂಮರೇಟರ್. ಇವಾಗ coulomb per meter square. Then the last one is volume charge density. So volume charge density is denoted by the letter rho. Idu charge per unit volume. So the unit is coulomb per meter cube. So we have three charge distributions like linear charge density, surface charge density, then volume charge density. So lambda, sigma, and rho. Okay, so it is defined, and according to the shape of the body we will define it. So linear charge density for the length, surface charge density for the area, volume charge density for the volume, and the units are in front of you like coulomb per meter, coulomb per centimeter square, coulomb per meter cube. Okay, so this is regarding the charge distribution. Idr mele namge questions baratte, matte idu Gauss law application study madbekadre namge idradu help agutte aita. So don't forget, remember this one. Then, so the last concept for today's class, that is the electric field intensity. Derivation next class al nodana. Okay, so electric field intensity, what is the meaning here? The electric field intensity is defined as, first, it is denoted by the letter E. The electric field density is denoted by the letter E, and it is a vector quantity. So ನಾನು ಅದಕ್ಕೆ ಇಲ್ಲಿ arrow mark ತಗೊಂತಾ ಇದ್ದೀನಿ. It is defined as force per unit charge. It is defined as force per unit charge. You can see the electric field intensity at any point due to source charge is defined as the force experienced by the body per unit test charge at that point without disturbing the source charge. So illon charge irutte, source charge anta irutte. So when the test charge you are bringing it to the system, illi system alli ಏನು differ ಆಗಲ್ಲ. So that is called as what? Electric field intensity. So how much force you are experiencing for that test charge in a given system is called as electric field intensity, ಅಥವಾ electric field ಅಂತ ಕೂಡ ಕೆಲವರು ಯೂಸ್ ಮಾಡ್ತಾರೆ. Right? So here you can see the expression. It is given by E is equal to force per unit charge. ಇಲ್ಲಿ ಅವರು ಲಿಮಿಟ್ ತಗೊಂತಾ ಇದ್ದಾರೆ, that is Q naught is tending to 0. And the SI unit of this electric field intensity, you can see the force is expressed in terms of Newton, charge is expressed in terms of Coulomb. It is Newton per Coulomb. Okay, so this is regarding the electric field intensity, its unit and the formula. So next we have the derivation, that is electric field intensity due to the charge along the axial line and along the equatorial line. So that we will discuss in the next class. If anybody is having any doubt, we can discuss that now. So today's class, we have discussed about the electric charge. So electric charge discuss madidvi, the properties of the electric charge we have discussed. So three basic properties are there, and after that we have the three other properties for the charges. So conductors, insulators, nane nimge illi helilla, bekandre it is just like which will allow the passage of the electricity is called as the conductors. All metals are the examples. Actually, year syllabus alli delete agide adu. Then the insulators, which are having the high resistance or which will not allow the current to pass through them, is called as the insulators. Plastic, nylon, wood are the examples. Kadege properties anna nodidvi, additive nature, conservation of charge, quantization of charge, then the unit of charge, then very important, the Coulomb's law. Yes, the Coulomb's law expression, its vector form. Here some constant values we have discussed, like 1/4 pi epsilon naught value in baratte, kadege epsilon naught value in baratte, what is relative permittivity. Then principle of superposition ಅಂತಂದ್ರೆ just ನಾವಿಲ್ಲಿ add ಮಾಡ್ತೀವಿ, ಕಾಮನ್ ಇದ್ದದನ್ನ ಹೊರಗಡೆ ತಗೊಂಡು ಸಮೇಷನ್ ಹಾಕ್ತೀವಿ, ಸಿಂಪಲ್. Charge distribution, linear charge distribution, surface charge distribution, volume charge distribution. Unit for that, ಇದು ನಮಗೆ ಗಾಸ್ ಲಾ ನೋಡ್ಬೇಕಾದ್ರೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. Then the last part is electric field intensity, the expression for electric field intensity. So this much we have covered today. Next class, dipole, electric flux and the Gauss law. So we will try to do it in the next one class. ಆಮೇಲೆ ನಾವು MCQs ಕಡೆಗೆ ಹೋಗ್ಬೋದು. So for your NEET exam. Yes students, anybody is having any doubt? Understanding ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಮಾಡ್ಬೇಕಾ ಕಡಿಮೆ ಮಾಡ್ಬೇಕಾ ಇಷ್ಟೇ ಇಲ್ಲ? What is your opinion? So you can speak freely so that we can understand your what you require. Otherwise you can chat. Yes. Anything from your side? If you're facing any difficulty for the class 6 to 7, I hope it is convenient for everyone. Class timing. So 6 to 7 it is there, but 6 to 6:45 teaching will be there. After that, if you revision 5 minutes, then 5 minutes, if you have any doubts, we can clarify that. That's from your side. Yes. So Harshita, the next other students, if you reply, it will be good. So if you require this part notes, very soon you will get the, what we can say, that is books you are getting from the Sankalp. Hard copies you will get. If you require the soft copies also, you can tell, we will provide you. Yes, Priyanka. Okay. So if anything is there from your side, you can tell me. Otherwise, we will end the session. Next class on Wednesday, I have the next physics class. Okay, students. Thank you for your patience.